Now we are considering an atom having a nucleus which is having a charge of Ze, around which there is one electron revolving. So what are the types of energies that this particular electron has? So it will be having two types of energies. What are they? As it is moving, it will be having kinetic energy. As it is away from to a certain extent, it will be having some potential energy. So the total energy, what will be the total energy? Total energy will be equal to the sum total of kinetic plus potential energy. That will be the total energy. So that is equal to, what is kinetic energy? Half mv square. And what is the kinetic energy of a charged, or sorry, the potential energy of a particle having a charge? It is k q1 q2 by r. Is it? So here q1 is the charge of the nucleus and q2 is the charge of the electron and r is the radius of the orbit. So what will be the total energy? Half m v square into k z e square by r. Let us assume it as r m. But we have derived an equation for this particular term already. See, look at this particular equation. M v square is equal to k z v square by r n. So this value can be replaced in this equation. So we are replacing m v square is equal to k z e square by r, here it is r n in this equation. So replace mv square with kz e square by r n. So what will we get? Half k z e square by r n minus k z e square by r n. So what is common here? Kz e square by r. So take that as common. K z e square by r n is taken common. So what is left? 1 by 2 minus 1. So let us denote it as E n. So E n equal to k z e square by r n. So this is, we are taking LCM, we will be getting minus 1 by 2. So E n equal to half k z e square by r n. R n. So this is the expression for the total energy of an electron whose nucleus is having a charge of Ze, which is orbiting in the rnth orbit. See, if we are considering the value here, the energy is negative. Also, when I have reduced the expression, I have given a negative value for potential energy. Why? As the distance increases, what should happen to the potential energy? It should increase. So here we are having a positive value for nucleus and negative value for electron. So the total product will be negative. So if R increases, what is happening to the total value, gross value? It is increasing. So in order for that, we are considering the negative value here. So there is a small correction in the expression for total energy. See here, we are left with half here, but that was not placed here. So let us replace the value of 2. 2 was not placed here. So what will happen? So here also there will be a 2 and there will be a 2. So what will happen to the total energy? E n equal to, if you are cancelling the minus 2 pi square m k square e power 4 by h square into 1 by n square. So as said before, all these terms are all these terms are constants, and it will be having a value equal to minus, its value is 21.76 into 10 to the power of minus 19. What is the unit of energy? It is joules. So there is one n square left into n square. But when we are calculating the energy in atomic level, it will be calculated in electron volt. So 1 electron volt is 1.6 into 10 to the power of minus 19. So let us replace and convert the from joules to electron volts. So minus 21.76 into 10 to the power of minus 19 by 1.6 into 10 to the power of minus 19 electron volt. So here there is n square, don't forget that value, and so we will be left with minus 13. If you are substituting and simplifying this equation, we will be left with by n square. So the energy, the total energy of an electron revolving in the nth orbit of hydrogen atom is minus 13.6 by n square electron volts. We suppose if we are calculating the energy of the first orbit, it will be minus 13.6 electron volts itself, because value of n is 1. E2 will be equal to minus 13.6 by the value of n is 2, and so it is 4 electron volt. So that will be around minus 3.4 electron volt. So here first orbit, the energy is minus 13.6 electron volt, and in the second orbit the value of total energy is minus 3.4 electron volts. Similarly, what will happen to the other values? As the number increases, the energy, total energy of the electron in the orbits will also increase. So what will be the value of energy of an electron which is far away, or which is at infinite distance from the nucleus? We have to substitute the value of n to be infinity. So something by infinity, what will be its value? So E infinity equal to minus 13.6 electron volt by infinity, which will be equal to 0 electron volt. So something by infinity is 0. So we don't need to supply any energy to the electron in order to pull it away from the atom if it is at an infinite distance from the nucleus. So this is very evident. Now see, E1 equal to minus 13.6 electron volt and E2 equal to minus 3.4 electron volt. So suppose if you want to bring the electron in the second orbit of the atom, we have to supply an energy equal to 3.4 electron volt. Suppose if you are supplying an amount of energy of positive 3.4 volts, so when we are supplying the energy, it will be having a value, positive value 3.4. So plus 3.4 and that 3 minus 3.4 will be cancelled, and hence we can bring that electron from the second orbit outside. So this is the physical significance of this one. If you want to pull out the electron from the first orbit, so the amount of energy that you have to supply is plus 13.6 or more than that. The minimum amount of energy that you are supplying here should be 13.6 electron volt. Only then you can pull out the electron from the first orbit of the hydrogen atom. But you don't need to supply any energy which is for the electron which is away or very much far away from the nucleus, and the amount of energy that you should be supplying decreases as the distance from the center of the nucleus increases. See, it is very evident from this equation. As the distance from the center increases, the amount of energy that we need to supply to remove an electron is very less. If we are removing an electron, see, suppose assume that there is a nucleus and there is one electron here, and we are going to remove this electron from this particular atom. So after we remove, we are left with only the nucleus. There is no electron. So basically the atom is neutral because of the nucleus, positive nucleus and the negative electron. Suppose we are removing this one, what will happen? We are removing the electron from the atom, and hence what will be the value here? It will be having only a positive value. So we can say that the atom is ionized. It is being converted from atom to an ion. So that amount of energy required to remove an electron from any electron is known as the ionization energy required for that particular orbit. So from this we can define what is the ionization energy. Before knowing the ionization energy, let us see what is the ground state and excited states. This is the hydrogen atom. Here this is the center nucleus and this is the electron which is revolving, and assume that there are electron or orbits here. Now when normally the electron is revolving in the least energy state, that is the ground state. For hydrogen atom, what is the value of ground state? It is minus 13.6 electron volt. So this is the minimum or the least value of energy that the electron will be having when it is revolving in the first orbit, because hydrogen has only one electron and hence it will be revolving in the first orbit, and that value of energy is minus 13.6. This is the ground state. Okay, now I will supply some sort of energy to this one. For example, I am supplying 3.6 electron volt to this electron. So what will happen if you add 2? the energy now will be minus 10.0 electron volt. So assume this is not the ideal case, I am just assuming a value. So if you are supplying a value of 3.6 electron volt to this particular electron which is revolving in the first orbit or the ground state, what will happen? It will obtain some energy and it will be going to that orbit, which will be having a value of 10.6 electron volt. So when it is going to such an orbit, here it is said to be in an excited state. So here when it is revolving in the first orbit, the value of n is 1. That is the ground state. It is the ground state. But when we are supplying certain amount of energy and the electron is moving to the next energy level, so it is in the first excited state. If you are moving to the next, the neighboring orbit, then we say that it is in the first excited state. Suppose if we are giving more amount of energy, that electron might be going to some other orbit. So that will be a different story. But now I am considering only the case of the electron moving to the next energy level, and that will be called the first excited state. So if we are increasing the amount of energy to infinity, and so from that we can pull out the electron from the atom, and hence the atom will be in short of an electron, and it is called an ion because it will be having only a positive charge. Now we should discuss what is an ionization, what is ionization energy. Now I took an example and said that I am supplying an amount of 3.6. That is not an ideal value. I just assume that I am supplying that amount of energy to the electron, and so it will be converting to some other orbit. So we will define what is ionization energy. The minimum energy required to take an electron from the ground state to n equal to infinity is called ionization energy. So when an electron is in the ground state, and if you are removing it or taking away from the nucleus or the atom, then that amount of energy that we are supplying is called the ionization energy. I hope the things that we have dealt up to this topic is very clear. So as far as we have dealt, the important things are the derivations for energy, radius, velocity of the electron in the hydrogen atom. So as an extended activity, you can find out the values for these terms 1, 2, 3. I have directly written the values of these terms, the fine structure constant and the value of R, the expression for energy. All these terms are constants, and hence we can substitute the values and find out if it is correct. It is to be done as a homework.